Hello everyone, and welcome to part 3 of the Prerunner project. Before I dive into this build, I want to make clear that all of the content in this video has already been shown previously as a part of the regular project update videos. So if you've been following along for a while and have been watching all of them, then you've already seen all of the content that is here, but be sure to check out this week's new update video, which I have uploaded at the exact same time as this one. But with that said, here is part 3. I started off by doing some sanding on the cage and roof rack pieces, in preparation for painting. I usually like to sand the entire surface of a part prior to painting when using a resin coating like I did here. I will still use the file in a few spots where the resin was a bit thick, like in some of the corners. I got several questions on the last video regarding why I chose to use a resin coating as opposed to using acetone to smooth the surface of these parts. I chose a resin coating because I wanted to print these parts in PLA rather than a material such as ABS, which can easily be smoothed with acetone vapor. I don't do a whole lot of printing in ABS, so none of my printers are really set up for it, and when I do print something in ABS, it's usually just a relatively small, simple part. But for a large print like these cage pieces, which require a lot of time and material to produce, I prefer to use PLA since it's much easier for me to print, and it's far less likely I'll encounter any warping or any other issues while printing. Also, as a positive side effect of using a resin coating, it helps strengthen and stiffen the cage. But if I had the means of reliably printing these cage pieces in ABS plastic, I would definitely consider doing so and choosing a method such as acetone vapor smoothing to achieve a nice surface finish, since that would cut down the amount of time spent sanding. I will be showing some other processes for smoothing 3D printed parts, including using acetone in future videos. Right after sanding, I sprayed a few light coats of primer. I ended up running out of the primer I was using for the cab piece, so I used a different brand for the rear section. That's why they're two different colors. With the cage pieces looking good, I next did a little bit of work on the body. I decided it would be easier and look better to cut out the windows prior to painting the body, and then install my own after the body has been painted. At first I started cutting the windows out with a knife, but this body was made from some thick polycarbonate, so for the sake of saving time and effort, I just used a rotary tool to hack away the windows. I'll still do a little bit more sanding around the edge before I paint the body. On the chassis, I decided to reinstall the front body mount since I'll be utilizing it to secure the front of the body. I've been brainstorming some ideas about where I want to place the battery. I decided to mount it on the very front. To secure it, I designed and printed a custom battery mount. For a while now, I've received a lot of comments from people who want me to show more of the design process for creating parts, and from those who want to learn how to be able to design and print their own custom parts for their RC vehicles. I thought this battery mount would be a great part to demonstrate the design process I used to create it, and to demonstrate just how easy it is to create simple custom parts for your vehicle with just basic CAD knowledge. This is by no means meant to be a step-by-step follow-along tutorial or anything like that, just kind of a general overview of how I went about designing this part. Hopefully this will help those of you who want to create your own custom parts get some ideas and inspiration. I started by measuring the dimensions of the battery pack so I would know how big I needed to make the mount. With those dimensions, I began making a simple sketch using CAD software. To design this part, I decided to use Autodesk Fusion 360, but a simple part like this could be easily made using just about any 3D modeling software. When designing this part, I made sure that there would be plenty of room for the battery, so I oversized the interior cavity by at least 2 or 3 millimeters to ensure that the battery wouldn't fit too tight. In this situation, I wanted to lean on the side of having the battery holder being a bit larger than what I needed. If the battery ends up being a bit of a loose fit, and I end up needing to use a little bit of foam on the inside for padding, it's not a big deal. But if I lean towards the side of making this holder as tight and snug fitting as possible, I run the risk of making the battery too small and having to reprint the part. I can be a lot more relaxed about the dimensions and tolerances when I'm making sure there is plenty of room. While modeling the part, I thought it would be cool to make the front of the mount look a bit like a radiator, so I incorporated that into the design. One thing that I think is very important when doing any kind of design work, especially if you are a beginner, is to always start with a basic sketch before you start modeling, whether it be just with a pencil and paper or within sketching or drafting software. I often like to get my ideas out on a paper and kind of come up with a plan of how I want the part to look, what functionality it needs to have, and things like that before I start modeling the part in CAD. And also, I'll often be able to identify some potential issues or areas where I can make improvements to the design just from a rough sketch. Now, since this part is very simple and I had a pretty clear idea of how I wanted it to look in my mind, I didn't end up sketching anything out, I just dove straight into the design. I'm very pleased with how this part turned out. The only thing that I forgot to do was add at least 1 or 2 additional magnets to the opposite side of the cover, but as you'll see, I end up using a little bit of tape to act as a hinge, so it's not an issue. The slicing software I used ended up removing 2 of the fins on the radiator, which I didn't notice until after the part was printed, but regardless, I think it still looks fine. In total, I spent less than 10 minutes designing the part, and it took about an hour to print, and I'm very pleased with the finished result. I wanted to demonstrate just how easy it is to make a custom part like this with just basic CAD knowledge and a standard FDM 3D printer. With those 2 things, you can create all kinds of useful parts for your builds. I'm also going to be making a mount for this, which is going to screw onto the front of the chassis, which you'll see in a minute. I wanted to make the battery holder and the piece that secures it to the chassis to be 2 separate pieces, because it'll be a lot easier to simply secure the mount to the chassis and then glue the battery holder to the mount, rather than making it one piece and having to worry about the precise position of where the mount is located. Again, the chassis mount is a very simple design. I decided to add a loop to the top in case I wanted to use it as a tie down for the wires. I went ahead and screwed the mount to the front of the chassis. Before gluing the battery holder to the mount, I first used a bit of super glue to secure the magnets for the side door. As I mentioned earlier, I should have put a few magnets on the other side of the battery door, but I just used a small piece of tape to secure it. To secure the battery holder to the mount, I used shoe glue as an adhesive. I wanted to work on the position of the body. I needed to remove some material from the back side of the cab so the body will sit lower on the chassis. I marked the position of the slipper clutch shaft and used a rotary tool to remove material. PLA is not the nicest thing to sand since it tends to get soft and melt while being sanded at high speeds, but the sanding drum cuts through it like butter. I checked to see how well it fits with the cage in place. I did need to remove a section around the slipper clutch shaft, but I'm going to try to avoid removing any material from any other sections of the cage that runs along the back side of the cab. I noticed that the rear cage section was sitting a bit too high, so I needed to sand down the posts that sit on the chassis. At first I used a file to sand around the raised center section, but doing this was a bit tedious, so I just cut off the ends and used a rotary tool to sand down that section of the cage until it's at the height that I want. I'll add new guideposts to replace the ends that I cut off later on. After a bit of sanding, I got the rear section of the cage to sit at the height that I think looks good. I'm not a huge fan of the grille that's on this truck right now. It's a nice design on the full-scale trucks, but since this one's molded polycarbonate, it doesn't have a very realistic appearance. I decided to design and print my own grille. The one I designed is more reminiscent of the grilles used on 1967 to 1970 Chevy trucks. I printed the grille you see here using an FDM 3D printer and PLA plastic to act as a prototype and to test the fitment. I will probably be reprinting this using an SLA printer once I verify that the grille looks and fits how I want it. I cut the bumper and grille away from the rest of the body. Although it's probably obvious, I won't be using this bumper either. I will be making my own custom designed one. After cutting it away, I wanted to get an idea of how much material I needed to sand away with the sanding drum in order to get the grille to fit properly. It looks like I did a good job of designing the grille. It fits perfectly, and I think it looks much better than the old one. As you may recall, I cut out the windows since I will be painting this body, and I figured it would be easier to remove the windows and install new ones instead of tediously masking them. Doing so left a rough edge around the perimeter, which I wanted to sand smooth. I started by using some sandpaper in a few spots, as well as a rotary tool with a small grinding bit, which works well in rounded corners such as the lower corners of the windshield. I used a hobby knife in a few areas like the front vent windows where the space is too small to sand. After sanding all of the edges, I moved on to sanding around the back of the cab, where the 3D printed piece is attached to the rest of the body. I wanted to make the transition between the two pieces as smooth as possible. I also wanted to trim a little bit of material from the bottom and sand that section smooth. Because I will be painting this body from the outside, I sanded around the entire outer surface so that the primer and paint will better adhere to the surface. I decided to fill these dimples on the hood with a little bit of Tester's contour putty. The purpose of these is to mark where the holes should be drilled for mounting the body onto certain chassis. Since I won't be drilling any holes into the body, filling and sanding them smooth will look much better. I simply spread a little bit of the putty onto the surface and then let it dry and then sand it smooth until it is flush with the rest of the hood. I had an idea for creating some hood vents that look like the ones here, which I wanted to try out on this body. I started by roughly sketching the shape and size that I wanted the vents to be. I then began modeling a piece that will be glued to the underside of the hood. This piece will form the sides of the vents and give the section that will be cut and folded down a place to be mounted to, as you'll see later on. Designing this part was very simple. I just made two sketches that you see here, and I then extruded each sketch and used a Boolean intersect command to create the body. I then created an additional sketch to cut a section into the front. I mirrored the design, printed out both pieces, and positioned them where I wanted on the underside of the body. I then marked the position. I used a hot knife to cut through the body. Since this body is made from relatively thick polycarbonate, it doesn't cut through it as easy as it does through some thinner materials, so the cut ended up not being very clean. Because of this, I needed to do some additional trimming and sanding around the vent openings to make them as smooth as possible. After doing this, the cuts for the vents were looking much better. Next, I glued each of the vent pieces to the underside of the hood, making sure that they are lined up correctly and are as symmetrical as possible. I trimmed away any excess glue, and then I scored the body where it will be bent. I roughly measured the size of the vents and cut a piece of styrene to the correct size and shape. This piece will be placed on the underside of the vent and will provide a place for the body to be glued to. I used a little bit of heat to give the piece a slight curve. Once this piece was the correct size and shape, I duplicated it for the other side. With each fitted well, I glued them to the bottom of each 3D printed piece, and glued the tab I created in the body to the styrene piece. At this point, the hood vents were looking great, and I think they make an awesome addition to the body. If you would like to try something similar and plan on painting the body from the inside, you're really going to want to try and make the cuts a lot cleaner than what I did here, which would be a lot easier to do on a body made from a thinner material. And the parts that I designed and 3D printed could also easily be made from styrene. Since I will be painting this body from the outside, I wanted to do some sanding around the edges to further smooth them out. I also wanted to apply some milliput putty to certain sections, which I sculpted to the shape that I wanted, and then will later sand these areas. Milliput is a two-part epoxy putty, so equal parts of each component needs to be thoroughly mixed together before applying. Once thoroughly mixed, I begin applying the putty. I use some water to thin it down and to help make the surface smoother. I also applied the putty around the back of the cab where the two parts meet. I let the milliput set overnight. The following day, I was ready to sand. Since I spread it on thick in the back, I started with a rotary tool and then moved to sandpaper and a file. At this point, the body is ready for a coat of primer. This will help to identify any sections that need any further sanding. Moving on to the cage, I spent some time brainstorming how I wanted to mount the cage to the chassis. I started by making the rear section be able to be secured to the factory body post holes on the back. To do this, I started by drilling some pilot holes, followed by 3mm holes for metal rods to be inserted into. I marked the length that I wanted the rods, cut them to the correct size, and glued them to the cage. This will aid in positioning the rear half of the cage. I plan on securing the cage and body using magnets, which I will be showing in a future video. I moved on to painting both cage pieces, first masking off the rods. I started by applying one final thick coat of primer, followed by several thick coats of paint. For a part like this that has been FDM 3D printed, I find that laying on the paint really thick helps to smooth out the surface and make the individual layers less visible. Using thicker paint like this Rust-Oleum satin black I'm using seems to help as well. Here's a look at the finished painted cage. I'm very pleased with the finished result. Taking the time to apply a resin coating and many coats of primer and paint has paid off. So while I was waiting for some of the parts on the Firebird to be printed, I did a little bit of work on a roof rack that I designed and printed a while back, which I'll be using on the K10 Prerunner build. Both the roof rack and the resin coating I applied to it are a bit rough, but it's nothing a little bit of sanding and filing can't take care of. Plus, I'm not worried about trying to make this roof rack look perfect. I started by filing away any of the larger imperfections, especially those that are visible from the top, which will be the most visible. I then used some sandpaper to reach the tighter areas, and to help give the overall surface a smoother finish and prep it for primer. I also made sure all of the lights would fit onto the front. After I finished sanding, I wiped away all of the dust and began layering on some primer, which will help to smooth the surface. With the primer applied, I did a little bit of light sanding in a few areas, and then applied several thick layers of paint. In between coats, I worked on the lights, cutting and sanding until the surface was smooth. For the lenses, I used thin pieces of clear plastic, which I cut to around 11 millimeters in diameter. I used some silver paint for the inside of the light buckets, and some black paint for the outside. Once the paint was dried, I glued the outer ring to the light bucket, sandwiching the clear lens in between. Finally, I mounted each of the lights to the roof rack using M1.6 by 5mm screws. This roof rack turned out great, and is going to make an awesome addition to the Prerunner build. I will be adding this roof rack to the Make It RC Thingiverse page, either by the time this video is uploaded or shortly after. It's definitely not the easiest thing to print, but the results look pretty sick, especially once I get some LEDs installed. I started by soldering all the LEDs in series, taking note of which sides are positive and negative. After they were all wired, I did a quick test to make sure they were all illuminating. After confirming that they all worked, I applied a little bit of heat shrink to cover the solder and cut away the excess leads. Next, I removed each light bucket from the rack to make installing each LED easier. I used a little bit of glue to secure each LED into the light buckets. After all of the LEDs were in place, I remounted the light buckets. This roof rack looks great with the LEDs installed and is definitely going to make an awesome addition to the truck. Another item that's going to make a great addition to the truck is some custom front Prerunner style fenders. I scanned the body a while back, and I'm using that scan to aid in the design of this piece, which I'm modeling in Blender. I found that coming up with a design that I liked was a bit difficult since these fenders have to accommodate the larger than scale tires, so therefore the wheel openings have to be very large. I also couldn't find a whole lot of relevant reference images of huge fenders on this body style of truck. Despite this though, after a bit of messing around with the design, I ended up with a result that I was satisfied with. I printed out both fenders and test fit them to the body. The fitment is great, and I really like the wild look of these larger fenders. So far I'm very pleased with how this build is progressing. It's really starting to take on a pre-runner or trophy truck style look. Getting the body mounted, designing some bedside pieces, and getting the body painted are the next steps for this project, as well as making a custom front bumper and adding the interior. Thank you for watching, and I'll see you next time.